Good morning, afternoon, or evening. How you doing? Welcome back to Mr. Morrow's Algebra class. Yesterday we learned about rate of change and slope. Today we're going to simply focus in on slope. They're both the same thing. Remember that, my friends? The skills are exactly the same. Please remember that the only difference between slope and rate of change is that the rate of change actually involves units. So a slope you may see as 2/3. But if it's a rate of change, maybe it's 2 feet every 3 minutes, for example. That would be a rate of change because you added the units. Okay? Now, as far as slope or rate of change is concerned, we're just going to deal with slope today. So that means we're not going to involve actual units. But slope is a ratio of what, guys? What is slope a ratio of? Think I heard it. Rise over run, which is a vertical change over a horizontal change. Basically what's happening is slope describes the change in y over the change in x. Hence, vertical change over horizontal change. Whenever we're talking about the vertical axis, we're talking about the y-axis, so that's why vertical change is the change in y, or the dependent change. And horizontal is the x-axis, so that's a horizontal change, a change in x, or the change in independent variables. Now, slope can also be described as a rise over run or a fall over run. And how can you tell the difference? Very easily. You rise if the slope is positive. You fall if the slope is negative. But you're always going to run to the right. We haven't seen how this works yet, but I promise when we do, all of this stuff is just going to click and you say, oh, okay, I know what he means now. Run to the right. So positive numerator, you're going to rise. Negative numerator, you're going to fall. But you always run to the right. The run is always positive. The denominator is always positive. And then we also talked about the slope formula, which is what? No, y equals mx plus b is the slope-intercept form of a linear equation. What is the slope formula, though? How do we find slope? There you go, y2 minus y1 over x2 minus x1, where x1 and y1 and x2 comma y2 are ordered pairs on the line. Got to memorize that formula, my friends. Got to. Slope formula is y2 minus y1 over x2 minus x1, where x1 comma y1 and x2 comma y2 are points or ordered pairs on the actual graph or line. Please remember also that the slope or rate of change of a line is constant throughout its own linear equation or function. So this was just basically a review of yesterday. Now, I'm going to continue reviewing with some actual examples. Okay, again, slope equals m. Slope, or m, equals y2 minus y1 over x2 minus x1. What is the slope of the line that passes through the given ordered pairs? Okay, for A, can anyone simply by looking at this, seeing the two ordered pairs, can anyone immediately tell me what the slope is? Immediately right off the bat. No? 0. Yes. Why? When the y's are the same, your slope will equal 0. Out of curiosity, what would the equation be? I know it's a straight line, but what would the equation be? -2. Very good. Remember, guys, this is what's happening here. Here's your x, here's your y, here's your -2. You have this straight line going through here. Isn't every single y value going to be -2 at this point? So that's why when the y's are the same, the slope is 0. If I asked you for the equation, it would be y equals negative 2 because y is negative 2 forever on this particular line. Okay, B. Label, 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 label. x1, y1, x2, y2. y2 minus y1 over x2 minus x1 equals negative 4 plus 7 is 3 over 6 minus 5 is 1. Does that make sense? Okay, let's look at C. Can anyone right off the bat tell me what that slope is? Undefined. Why? Because the 5's here are the same. When the x's are the same, your slope will equal undefined. Okay? Does that make sense, boys? Okay, now, the fun one. The one most people do not like. But that's okay. Because you got to be able to do this. You have no choice, unfortunately, my friends. Label, label, label. x1, y1. x2, y2. Now just follow the math. y2 minus y1 over x2 minus x1. That's going to equal negative 5 over 5 divided by negative 2 over 4. Let's first simplify. Negative 5 divided by 5 equals negative 1. Very good. Over, what does negative 2/4 simplify to? Negative 1/2. Thank you. Now, how do I divide fractions? Stay, change, flip. Thank you. Stay, change, flip. So stay, change to multiplication, flip. Negative 1 times negative 2 is 2 over 1, and that's my slope. Does that make sense to everybody? You promise? All right. Please remember that I told you, I've been telling you all year, got to know your fractions. If you don't know how to do fractions, it's going to be a little difficult for you. May I continue? Okay. We want to find the slope of each given line. Remember, this is easy. Go ahead and find your first point, and then rise or fall and run to the next perfect point. So here, starting over here, and I'm going to go up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my slope is 4 over 14, which I must reduce, so it's 2/7. It's going up from left to right, so I know it has to be positive. Next one. Starting over here, because remember we always go from left to right. To get to my next point over here, I got to go down 1, 2, 3, 4, 5. And I got to run 1, 2, always to the right. So my slope here is negative 5 over 2. Remember, guys, it's constant. So if I want to find the next perfect point, guess what? I go down 1, 2, 3, 4, 5, over 1, 2, and look at that. That's perfect. Right on the bullseye. Slope is constant for the whole line, always. Is this making sense, my friends? Okay, next. From left to right. From this point on the left to this point on the right, I go down 1 over 1, 2, 3. So my slope is negative 1/3. And it's pointing down from left to right, so it has to be negative. And last but not least, I'm starting over here on the left. Want to go over here to the right. So I'm going to go up 1, 2, 3, 4, over 1, 2, 3. So my slope is a rise of 4 over a run of 3. Does that make sense, gentlemen? Promise? May I continue? You have a question? Yes, sir. When you're going to represent the slope, you can write m or slope. Yeah, but m is a lot quicker. And also, when we start working with the slope-intercept form, the m is what they're going to be asking for. But thank you. Yes, sir, you're right. Okay. What did I give you? A table now. It's no big deal. Label the table. Hey, I'm a poet and I didn't even know it. Okay. x1, y1, x2, y2. So, y2 minus y1 over x2 minus x1 is 4 over 2. What is that? What is that, Mr. Morrow? 4 over 2, which I have to simplify, so my slope is 2 over 1. B, x1, y1, x2, y2. y2 minus y1 over x2 minus x1. So my slope is going to equal negative 3 over positive 2. That's my slope. x1, comma y1, x2, y2. y2 minus y1 over x2 minus x1. That's negative 3 halves, and that is my slope. Come again? Oh, that was kind of silly on my part because they're exactly the same. Yes, okay. Let's make this better then. Let's fix this. Let's fix this. Let's do instead a 1. We'll go. Okay, how about this one? We got x1, y1, x2, y2. y2 minus y1 over x2 minus x1. It's going to be 6 over 2, which is 3 over 1. Does that make sense, boys? Alrighty. Thank you very much. Hope you learned a lot. Have a great day.